We've been mentioning a variety of the kinds of experiments that International Space Station crew members perform, and those experiments come in a wide range of their different scientific disciplines, some of it very deep and theoretical, some of it designed to learn more about how people can live in the space environment. And some of it is demonstrating concepts for technology that could assist future exploration to deep space. And today, Commander Kevin Ford performed one of those latter experiments. You're seeing some video that we recorded that was downlinked earlier today of Ford performing a European Space Agency investigation that's aimed at improving crew operations efficiency and their autonomy as well. Joining us this morning to talk more about CRUISE, which is Crew User Interface System Enhancement, is Mikael Wolff, a senior software engineer and ESA's lead and co-investigator for the CRUISE experiment, speaking with us this morning from his office at the European Space Research and Technology Center in Noordwijk in the Netherlands. Mikael, tell me about the background of this project and how you got involved in it.
Okay, good morning, Pat, first, and thanks for the chance to chat with you about this. Our group here at ESA and our industrial colleagues, we've been interested in improving the onboard user interface for a long time, essentially trying to make astronauts' performance improve and also get better, say, user satisfaction for when they're actually working up there. And the streams we've been doing this in is technology demonstrations, say, building block demonstrations, but we've also been thinking, say, more in larger term of trying to establish a path towards building a smart assistant, say an e-partner, to actually give a more broader support. I'd say that what we did today, the commander session with CRUISE, is a building block type of technology demonstration and also an operations demonstration.
Well, maybe a way to help understand this is to turn that question on its head. What is the deficiency in the way the crews operate now? What do you see in the current way that they operate that should be improved?
Well, first, I don't think it's only deficiencies. We do have some advantages with the electronic systems on board. I mean, we can carry less paper, and thereby we get things a little bit more cost-effective operations. But certainly, one deficiency is, of course, that it takes a long time to spin in technologies from ground into the space segment, since all validation and safety aspects has to be taken into account. And this is what we're trying to do. And especially, we've seen that for manual tasks, in-flight maintenance tasks type of things, the user interface that is provided today for the astronauts is not so-called task transparent enough, which means the user interface often gets in the way while they are doing their primary tasks, say adjusting a valve or doing a repair activity.
Their ability to consult the instructions is hampering them from doing the actual work.
That's correct. And we also seen that the operation, the actual instructions for avionics task, when you actually have to tune something deep down in the system, you usually have the operations content, the procedures, separated from the flight software displays. And one of our sub-experiments today is to go towards a design where we have both operations instructions and flight software parts in the same flow in the procedure, something that is not yet available on board.
We've noticed that part of this procedure has to do with the use of voice activation, and there's a piece of hardware that we saw in the video where that Kevin Ford was wearing, a little headset microphone, which is not brand new technology. Are you just trying to make better use of what already exists, or are you trying to develop something new?
I would say to a large extent it is a spin-in type of experiments. We're spinning in from the consumer market and what's available for us here down on ground. And indeed, as you noticed, it's a fairly normal microphone and headset he's using there. So, but a voice dialogue has not been available for crew before. There has been other experiments. Our NASA colleagues have indeed experimented with this, but moving from experiments towards actual operational interfaces has not yet taken place. And we're trying to learn more about this so we can, based on this experiment, we can design systems that are that this will actually work on.
And I noticed in some of the paperwork that one member of your science team is Italian astronaut Paolo Nespoli, an ESA astronaut. Has having his point of view, a veteran station crew member's point of view, helped you in your development?
For us, yes, it's always very important to have end users involved, as astronauts involved. And Paolo and also his other colleagues at European Astronaut Centers, for example, Frank de Winne, has helped us both in the development and in the testing. So it's not only for the final test, but we need all stakeholders, astronauts and operations engineers, to be involved throughout development and testing to get a product that we think can do the job that we expect it to do.
So how did it go this morning? Kevin Ford was working with in two sessions on the timeline here, with a procedural display and then with a voice-activated procedure viewer. Tell us how today's work went.
I could only follow it the same way you did, which was the voice loop and from video, and certainly the procedure display looked to go very, very fine. We were on time and we had the whole task completed. We will be very interested in seeing the data generated. Later on, it was the voice-activated procedure viewer that we did, and that task was selected to be as realistic as possible. So this was an in-flight maintenance task, and with in-flight maintenance task comes also, other issues. And I think there was one issue with the tools here. And that means overall that there was some time pressure, I believe, and a high workload on Kevin. And in such a situation, and this is part of what we want to learn about also, it is excellent to be able to do one thing, to do user interaction in more than one way, so voice and point and click. But it's of course easy to do the most the one that you're most used to first. So I believe we got some good voice commanding in there, but we have a mixture of both voice commanding and traditional commanding. So again, when we look at the data there, both the objective and the subjective data, it will be very interesting to see.
And I believe that Chris Hadfield is going to do a similar type of run for you later on, right? That's
correct. So thereby we cannot say, of course, that we have a full statistical, can do a full statistical analysis, but with two astronauts performing our experiment, we will have a much better idea than only the ground-based experiments that we've done before. That hopefully, we get the kind of insight we need to design these systems.
So what's the next step after Ford and Hadfield do this? You've said you need to look at the data, but what will be the next step for you and your team?
After analysis, I think we're heading towards more type of building block experiments. For example, having this so-called procedure viewer on a state-of-the-art tablet, and also adapt its user interface to something that we're more used to on the ground. This is also in cooperation with our NASA colleagues and the procedure group there. We are also looking at more wearable systems, so you should not have to be floating back and forth to your laptop for any reason, but you should be able to bring your equipment with you to your workplace, and we hope we can test these things in the near future. And of course, with voice, which is one of the new natural user interfaces, we hope we can implement a full dialogue. This time we only had full voice dialogue. This time we only had voice commanding, but the system itself was, in a sense, silent. It didn't really speak back.
Let's see. Is that the goal then in the long run? Are you trying, once this is all developed and implemented, are you trying to create a system where, like in science fiction, where people can talk to the computers and the computers talk back?
Or you could say it's a little. You could have that science fiction picture of a friendly HAL, but of course it's not only that you can talk; it's also what you're talking about. So it should be robust and resilient e-partner or crew assistant that can help the crew member, the astronaut, and the astronaut team to work together and share the tasks properly and give appropriate support depending on the individual's needs. And that is, then we've gone beyond building blocks and actually build a system. And hopefully we have a chance to do some of testing for this kind of system to support more autonomous operations when ISS can be used as an analog for a mission beyond low Earth orbit.
That sounds great. And actually, I was thinking more of talking to the Star Trek computer rather than HAL, but it's the same, same principle.
In principle, it should work that too.
Mikael, I appreciate your taking the time to bring us up to speed on this. It's very interesting. Thank you.
Thank you very much for being able to come on.
Mikael Wolff is a senior software engineer with the European Space Agency. He's the lead and co-investigator for the CRUISE experiment.